Hi guys, this is the Gigabyte motherboard we were looking at it on a previous video, the EP45C. Yeah, and when I got hold of this, all the MOSFETs on the VRM had been removed, so I replaced those because I happened to have some anyway. Once we'd done that, I found that the board then would just not start. So when you press the start button, nothing happens at all. Yeah, but if we connect the ATX power supply and bridge the green and black wire to force the ATX power supply to start, the board then, I mean, it had no RAM in, just the CPU and the fan on it, and it bleeped like to say there was no RAM. So it actually started. But after that, when I tried several other times to start it, I put some RAM in to see, oh well, it boot. And it wouldn't bleep or do anything after that. The post analyzer wasn't counting up, it was doing nothing. And I thought, oh well, something's changed. I took the RAM back out, it still wouldn't boot up. I had a little mess around with it after that, and I've actually managed to get it to bleep again. It seems to be an intermittent thing that sometimes with no RAM in, it'll bleep and you can see the post analyzer card goes to C1 and it kind of like crashes or keeps on bleeping. Yeah. And we had a look around at the standby voltage, and I was trying to find whether there was standby voltage on the on-off switch, which there was. There needs to be that, otherwise it'll never start. Yeah. We know the real-time clock's running pretty much just by looking at the current being drawn from the CMOS battery. We've got a good idea. I haven't checked it with a scope, but it's likely it's working. But I will check that next. And this is the Super I/O chip, so this is involved with basically monitoring the switch and sending the start signal to the power supply. Not necessarily directly, but it does send that. It sometimes goes through this Southbridge chip. So I had a look around this area, see if I could find standby voltage, and I couldn't. I looked around some capacitors, and at the time I couldn't see. So we concluded that video. I was going to try and find the schematic for this board and a data sheet for this chip. And the bad news is I couldn't find either. I found like a picture of this which tells you what pin is what, so I know which is the power pins, or supposedly. But it turns out, looking at that, it's not actually correct for some reason. I'll show you the data sheet that I have. So I found this. Yeah, it's not a data sheet as such, it's just a bit of a block diagram. So you can sort of see what this does basically. Yeah, and it also gives us a pin out. Yeah, and VCC here and here, you would assume that's the power coming in, and this AVCC, obviously it's red, it's power. We've got VBAT. Yeah, but the reason I know this data sheet is wrong is because VBAT, you know, when there's no power, I can have a look to see where, you know, effectively I know the CMOS voltage battery, so I can have a look and see where that's going to, and it doesn't. It goes up to a pin up here, which is really strange. It goes up to a pin on here, and there's power on the pin next to it. And when we switch it on, I get 5 volts on the pin next to it. So the power, the standby, seems to be around this pin called AVCC, but AVCC isn't actually the power coming in from the power supply, and VBAT is here. So I have a suspicion this actually is wrong for some reason. It certainly doesn't match mine. Okay, so that's what the data sheet said. So that was a little bit confusing, and I thought, well, is it wrong? I don't know. You know, but I had a look around, so I thought I've got another Gigabyte board kicking around in here. Let's just do the desktop. Yeah, I thought I've got another Gigabyte board here that I can't repair, and I wonder if it's the same chipset as this one. And this is the board I have. It's another socket 775, I knew that. And it doesn't have the same chipset. But what it does have is the same Super I/O chip. So I thought, okay, that's handy. So I had a look on this to see where the VBAT is, and it's the same as the other one, which doesn't match that data sheet. Now this board actually boots up. Yeah, when you power this up, it actually boots up. It's got a blown chip. Let me just zoom down on it a little bit. It has a blown chip here, you can see, and when I'm on standby, this gets warm. Yeah, and this is connected to this 1394 FireWire port, and I know that if you connect USB to that by mistake, you'll probably blow the chip, and I suspect that's what's happened here. So initially I actually ordered a chip for that, and it's actually, yeah, the replacement's here. But before I got as far as actually replacing it, I was asking on Badcaps forum, and somebody pointed out that I'm missing an adapter that fits in here, this NVSLI adapter. And this adapter basically enables the SLI, yeah, on the board. But if you don't have the adapter plugged in, even if you're not using SLI, you won't get a picture coming out, and that's what I've got. It boots up, but it doesn't detect the graphics card, yeah. And he said the reason it doesn't detect the graphics card is because this is missing. The guy says, I've done it myself, so I bought these in the past without this adapter, and they're useless, yeah. So I had a look on eBay, because it's quite an old board, I couldn't find. I could find almost the right one. I know exactly which is the right one. I could find something very similar. So I asked this guy, well, will this do? And he says, to be honest, I don't know. I can't tell you for definite. I can only tell you which is the right one. And all this adapter does is it connects some pins to other pins. And if I knew how that was wired, I could probably effectively cobble this to make it work just by bridging certain pins. But anyway, it's not really worth it. It's quite an old board. But what is handy is a Super I/O chip here is the same. So that's why I can't fix it. So let me connect this one up and I'll show you what I've found, and then let's have a look at our board, yeah? So give me a moment, I'll just get everything set up so we can actually do that. Okay, so this is the board, the other board, the one I can't fix because I don't have the adapter and I can't get one, yeah? So at the moment the power supply is off, and what I can see here on pin 3 of this Super I/O chip, yeah? If I just get onto that, this is difficult unless I look down the microscope. Actually, I can't do it on the screen. So, pin 3, yeah? And now I can't read the medium. I'm happy you can see there that there's actually 3.3 volts, yeah? Let me just do that again so you can see it. It's so difficult really wearing glasses because I find it so difficult. I can't see the meter and the microscope at the same time. I find it very difficult to work on the screen. Anyway, yeah, it's there. So that's the battery voltage, yeah? I can measure the voltage on the CMOS battery. It's the same, yeah, it's near as damn it. And then the pin afterwards, pin 4, there seems to be some sort of output that generates about 2.8 volts. Yeah, 2.8, yeah. And the pin next to it, there's nothing on it. The pin next to it, you can clearly see goes to this capacitor, yeah? Here. So, if we turn the standby on, what we now have is the VBAT and the 2.8 is still there. And this point here now has got 5 volts on it. Yeah, that's on the 4th pin down. Yeah, so that's what's happening on this one. Also, if we look at it's off the screen, but if I go to the pins that go to the switch that turns the power supply on the motherboard, the power on, that's got 5. So that's what that one's doing. Yeah. Now let's have a look at the other board. So this is the other board, yeah, and on this one, if we have a look, you'll see first of all the CMOS battery voltage is a little bit lower, yeah, it reads a little bit lower than the other battery. That's fair enough. So if we go to the 3rd pin, this is pin 1 by the way, counting like 1 anti-clockwise. That's why I know that data sheet doesn't match what I have, yeah. So there's a slight lag on the screen, doesn't help me, but this is pin 3, yeah, and there's your CMOS battery, 3.15. The next one is 2.72 on this, a little bit lower because the CMOS battery is a little bit lower, and I think that's what makes me think that voltage on that is an output being generated for some reason. The 5th pin in, and I said 4th by mistake on the video previously, is 0 volts. But if we connect the 5 volt power supply, I'll just plug that in, and I'll put the 12 volts as well. Okay, right, I'm ready to go with that. If I connect the power supply and switch on, look on this pin 5 now, yeah, 5th pin in. It probably goes to one of these capacitors, but anyway. So we just get on the board, yeah. So 1, 2, 3, 4, 5. This one, yeah. and there's 5 volts. So the voltage supplies between the two boards are basically the same. So I don't think this is like a standby voltage problem, which I originally thought. Okay, so I've got the heatsink off the south bridge on this. It's completely different. This is an NVIDIA chip. Our board we're trying to repair has an Intel, so the fact we're seeing different current draws from the real-time clock probably doesn't mean anything. This chip, generally, this will actually contain the real-time clock. This is the crystal. It's almost always like the tubular-shaped one, yeah. And you can see it's very close to this chip. And if we look on the other board with the NVIDIA chipset, again, it's very close to this chip, yeah. So that's where your real-time clock is. So, is our real-time clock running? Well, it should run all the time. It should run from battery, yeah. So, it should be running. The easiest way to check this is with an oscilloscope. I mean, I'm not really sure. Maybe a frequency counter. I've never tried that. But let's just get the oscilloscope and have it to see if we can see whether this is actually running. I'll just position the camera. Okay, so I've got the oscilloscope on, as you can see. You'll notice, by the way, I tend to use my analog scope most of the time. I've got a digital one here. It's just the analog one's just better to use in a lot of cases. If you just want to see something's working. And there's our real-time clock oscillator, yeah. It might have a bit of slightly bad ground colours and look a bit noisy. There you go. So that's our real-time clock, and that's running, yeah. So we know that isn't where the problem lies. So what can we do with this? Well, basically, we have a situation where we know there's power on the on-off switch. Yeah, we know that is getting power. We know that we've got the battery voltage going to here, yeah, and we know the real-time clock's running. And we know we've got 5 volt standby coming to here. So that would suggest everything is probably present that this requires to make it start. Yeah. We also know that if we force it to start by connecting the green line here, green to black here, and make it start, it attempts to boot. It actually tries to boot, yeah. But quite possibly because it hasn't been started as it should, you know, effectively I just force power on. Like it tries to boot up before all the voltage is stable, and that makes me wonder why sometimes it will kind of boot and sometimes it won't, yeah. We've got no information, no accurate data sheet for this, no schematic, and we have another board that is a different chipset, yeah, but it happens to have the same Super I/O. So you know where this is going, don't you? You know what I'm going to do next, yeah? This Super I/O is going to come off this boot that does start up, and it's going to go onto this board that doesn't start up. So let's change the Super I/O and see if that actually gets us anywhere. Okay, get onto that. See you very soon. So this is our donor board, yeah? This is our donor board. I put some caps on tape around all the close by components. Generally, the easiest way I find to desolder these things is to get leaded solder on all the pins, yeah, of the Super I/O, because I can always clean it off afterwards. And even if I bridge them all together with solder, I've taken the CMOS battery out, by the way, before somebody asks about that. I'm just going to get a good amount of leaded solder down each pin, yeah. I said if it bridges them all together, that's fine. There we go. I think I have actually managed to bridge them, most of them. I put a bit of flux on first, yeah. So by doing this, adding the leaded solder, it will actually protect the board and the chip, you know. So it will unsolder at a lower temperature and more easily, yeah. So let's just come down here, go with a good amount of leaded solder. And let's go down the other one. Okay, and now I'll just zoom in and show you what I've done, yeah. So get a good amount of leaded solder in here. Okay. So I'll zoom that down. You can have a look to see what I've been doing. One moment. I won't make you feel seasick, yeah. So here's our Super I/O chip, and you can see I've bridged pretty much all the pins. Couple not bridged down this side, so I'll just add a little bit more on that. It'll won't do any harm. It'll probably help if I can get some in on all of them. Yeah. Okay. That's it. Doesn't quite want to take there, but it's good. It's close enough. Right. Okay, now we've got it. So that solder will melt when I remove this. It'll make it much easier to remove the chip. And then if we wanted to use this board, you know, again, we could easily just clean all this stuff off. Yeah. So ESD11 tweezers. I bought some of these new ones. I mentioned I'd ordered some new ones off AliExpress. Yeah. ESD11. Yeah. The new ones. These I got in the UK. And look, the old ones, can you see? They're much finer tip, even though these are supposed to be ESD11. So I'm not impressed with that. I actually left them 4 rather than 5 stars. I mean, they work, but they ain't really exactly what they're supposed to be. But they were so cheap, it wasn't really hideous. I think I got 2 for like a couple of euros. But I'll definitely order some more from the UK. They'll keep me going. So hot air. Oh, I've got the caught behind the wire of the power supply. Let's go again. Hot air, 450 degrees, full airflow on my quick 861DW. Yeah. Let's see how easily we can actually get this chip off here. Moving my fingers a little bit further away, so you should see the solder melt down each side, yeah, when it's ready to go. I'll change hands. I'll go right-handed with the tweezers. Yeah. Solder's starting to melt a bit now. Call me in 1 moment. We have it, yeah. So that's the old one removed. So let's let that cool down, yeah. Okay, so while that was cooling down, I unsoldered the chip off the board we want to repair, yeah. So this is our EP45C, yeah. Exactly same method, solder all around the pins, yeah. And this is the chip I took off. And if you probably noticed before I started, I scratched a little X on it there, so I know that's the suspect one, yeah. The one that we don't want to put back on, because that'd be a bit stupid if if we just put the, yeah. That would be a bit stupid. Let's make sure we put the one off the donor board on, yeah. Okay, so I've added a bit of flux to that. So basically now we just need to clean up the solder pads on this, clean up the solder off the donor chip, and then stick it back on. Basically, so this is not so difficult. It's probably a good idea just to get a little bit of warmth into the board. Yeah, put a bit of fresh flux on. I'm not trying to melt the solder now. I just want to warm the area up a little bit to make life easier when we get the solder braid in. Yeah. So here's our solder braid and the iron. I just want to clean this off. There we go. So just going gently across the pads, just dragging like inwards towards the centre of the chip, yeah. And we can see this is all cleaning up quite nicely. Every helps you just turn the thing around, make sure just keep it in a nice direction, easy for you to work, yeah. Take the all this flooded solder off the end of the braid now. So we just do the other 2 sides. Get the big blob first, yeah, there we go. You see how easily this is just coming off, yeah? So again, I'll just rotate the board to try to get back in the shot where you can see it. Obviously you won't have this particular problem. Once again, take the big blob of solder and just literally clean each pad, yeah? And by having a blob of solder on it, I'm making sure that every pad has got a nice little coating of leaded solder on it. Okay, so that's looking fairly clean. Let's see, where are we? Yeah, there you go. Let's get the bit of isopropyl and a brush and just we'll just clean that up. Yeah, just get what I need. Okay, that looks pretty good, really. Quite clean, but we'll just get it under the microscope and we can have a look to make sure that you know, everything's ready to go. Yeah, so let's get the microscope. Okay, so we've got the microscope. I think you can see now there's a little bit of solder on some of the pads still. For instance, like there's one up here. You see that there just by the braid. So we can just clean up the ones that we might have missed slightly. There was one there. There's a couple down here. Although that bit of solder probably won't do any harm, to be quite honest. But I just want to try and get them all, you know, so they're fairly even. Yeah. The other thing I've noticed is that here, can you see it on the board where it says China? I've got a big splash of solder on it. That's from when I added solder to all the pins and lifted it. Obviously there was a good blob of solder. I don't think that's gone through the solder mask on the board, but I'll just clean it off anyway. We don't really want it on our board, so let's get rid of that. Yeah, so now we need to just clean this up again with a little bit more ISO. Check again for any pins that are not, you know, effectively looking flat. Like you can see there's another one there just under the braid. Yeah, there you go. I do believe I've got all of them now. And then yeah, we're ready to solder on the new one once we've cleaned it up. So let's clean the chip. So this is the chip, the one without the little X scratched in it. This is the donor, yeah. So now we just want to clean up all the excess solder. Probably the easiest way is just get a nice clean soldering iron tip, yeah, and just effectively just melt it and try and brush it off the chip, like so, a bit at a time, yeah. Let's just get it nice and clean. It might want a bit of flux actually on it. It's sticking a bit, yeah. So a bit of flux, not a problem. And I'll just see if I can actually get this to come off. If not, I'll use a bit of solder braid. Yeah, it's been a little bit troublesome. It doesn't want to come off that way easily. Okay, let's just stick it on the mat here. This is why my mat gets a few burn marks on it, by the way. But you know, these electronic workbenches are expected to take a little bit of this. So that's remove that one. There's another one a little bit further down here. That might just clean off anyway. No, wants a little bit of braid. And we just need to go around the chip basically with a bit of braid and just effectively clean off all this excess solder. Yeah, so again, it's just, you know, no rushing at it. Take your time and clean it up. So I'll just finish that off and then we'll see if we can resolder it. Don't be surprised, by the way, if while in the process of doing this you end up with some slightly bent pins on the chip. Yeah, it's not an issue. You can clean it up. You just have taking it off bit by bit. I've done most of it now. I just thought I'd show you the last part. I've now got just on a little bit of kitchen roll actually to protect my workbench a little bit more, to protect the mat really. There we are. Okay, because I'm just chasing these little bridges I'm going along it, and just keep you know, cleaning up the end of the braid, so you don't just, you know, actually put solder back on again. Yeah. You can kind of see as it melts, can't you? Just it's ready to come off. You see between the pins how it's all melting. The thing with this is you're going to end up with a lot of leaded solder on each of the pins, which is going to help a lot when you come to actually resolder it. So there you go. So there's our chip. Couple of solder bridges still I can just see over here, yeah. Just deal with them as well. Now when there's no bridges left, it's ready to go, yeah. So there's one here. Another one here. Right, that's looking good, guys. So let's get ready to resolder this onto the board. So here's our chip, yeah, ready to go pretty much. I've got it on the board, obviously. There's the mark there, which is for pin 1, and this is marked 1 here in the corner, so we know it's on the right way round, yeah. That's the first thing, put it in the right way round. The technique with this, basically, I mean, I think it's one of these things where some people, you know, seem to have their own methods with this. How I try to do it is to get the thing lined up in one corner perfectly and as close as I can all around, yeah. So it's kind of sitting in position, and then I'll try and tag a little bit of solder on the 2 pins in one corner. The problem with this, sometimes it moves while you do it, yeah, and it can be a little bit fiddly sometimes to get it. Generally, you shouldn't have to add any solder to do this, because there's probably be enough solder now on the board and on the chip to actually just tag it, yeah. If not, I mean, we can soon get a little bit of the 0.2mm, the fine solder, yeah, and just add a little bit. If we get a solder bridge, we can soon get it back off again. So while it's in position, I try not to move it, and try to get one end to solder. Come on. If it moves, it moves, yeah. Is it moved? Okay. Another way, we can try and hold it. Sometimes I find with my fingers is the best way to hold it. So it looks lined up. I can only see one end of it now, really. Yeah, it looks like it's lined up there. Let's try now, so just get that one pin. So I've tagged the pin down now. Yeah, I can still move it a little bit, but I've got it's fixed by one point. Yeah. The best place probably now is to go to the opposite corner. Yeah. So this end, and try and tag that as well. I think I've got a little solder bridge, but I'm not worried about that. I'll put a little bit of flux on it and I'll soon deal with it. Okay. Just coming in with a clean soldering iron, so we can just... I'll probably have to turn it round, guys. It's kind of like upside down to me, yeah? Let's go the opposite way around with this. Once you've got 2 corners stuck down, you've kind of like won, you know, most of the battle, basically. We'll clean a bit of space on my bench and get into position. There we are. So this is the corner I've obviously got a bit too much solder in it, yeah? But this is half the battle. In fact, it's 3/4 of the battle. Once you've got it in position on 2 corners, the rest of it is not so difficult to do. Okay. Let me see now. Is it lined up? And so I'm looking down all the sides now. I mean, I can see the occasional slightly bent pin, yeah? But they can be straightened up, that's not a problem. This side's all nicely lined. That side looks nicely lined up. End one might just be slightly bent. This side's okay, this is just slightly bent here, yeah? But that is good. I mean, there's no pins shorting, they're all pretty much sitting on the pads, yeah? So what we'll do is now we'll tag. Let me just find my tweezers. I have to put my glasses on so I can see them, of course. Okay, here we go. Let's just straighten up this slightly bent pin that we had, yeah? I'm not sure if you can actually see it as well as I am in the microscope. Those are the wrong tweezers. Those are the new ones, which are no bloody good. Yeah, so I've got a slightly bent pin here, but I can just move it out slightly, line it up. It's lined up, and I can solder it. Yeah. Well, let's get all 4 corners so that they're held. Okay. Again, you see, I'm using my BC3 tip. I sometimes will use a smaller tip on these sort of chips once I get them actually in place. Yeah. But the beauty of this is it actually gets enough heat into the board to actually solder. As you see, if I make a solder bridge in the meantime, it's not an issue at all. You know, not a big issue. It's not even an issue. Take a bit of solder. There we go. It's got it. So that's that one. Sorry, I'm sorry. I think I was out of view for that. I have a different. Like, you know, the width of the field I can see is much wider than you can see, unfortunately. Let's just check the focus again. Let's see what I'm doing properly. Sorry if you couldn't actually see on that last one. Okay, so once again, I know it's in the field of view for you. You know, the beauty of these microscopes, that you have such a wide field of view when you looking through the microscope. I'll do a. Trouble is, you can't really do a video on these microscopes because unless you've used one, you just don't understand. You know, it's like kind of like advertise like HDTV on a non-HDTV. They used to do, you know, like they'd have adverts. So you're watching on your standard def telly, yeah, and they're trying to show you how good the HDTV is, and you can't see. I'm sure that was like always one of the things. How the hell do we get out of this? You know, how do we show you how good our HDTV is when you're watching on a standard def? Okay, I think you can see, hopefully, that I've now straightened that corner pin, yeah? So let's just, again, tag this one on. It's on. Again, I should have put a little bit of flux on there, to be quite honest, just to get a nice soldered joint. There we go. Right, so there you are. There's two kinds of ways of doing this now. Some people use hot air and try and solder the whole chip, and some people like drag solder all the way along with a normal soldering iron, then come back and, you know, clean up the bridges. I tend to do it the way by dragging the soldering iron. But I'm going to have a bit of experiment with this one and see if I can actually solder it back on with hot air. So I've not tried this particular method before, but let's see if we can do it that way. Yeah, see if we can hot air this back in place. It might actually be better than the way I normally do it. So first of all, I want to be sure that all the pins are actually lined up. Yeah. I don't think this is going to go on with hot air. I'll tell you why. Because it's a recycled chip, some of the pins are not exactly sitting flush to the board. Yeah, they're kind of hovering a bit above it, and they're not going to solder. I can see that now. So I'm going to have to do this by my method of drag soldering. So I'll do part of it, show you how it's done, and then save this becoming yet another very long video. I'll go and finish the job off. So the way I do it, first of all, let's go for this area. Yeah. I add flux. Okay. First of all, I get flux on it. Then I take the fine solder, yeah, and I effectively stick some on the board, so, or rather on the bottom of the tip. I mean, yeah, I'm in shot, yeah. A bit on there, and I kind of like just push down. Yeah. Okay. Sometimes you'll get a solder bridge. It's not an issue. Push down, yeah. So I've done this area. You can see I've done this area several times. I've got a solder bridge on the last one, yeah. So the solder bridge, I'll just clean the end of the tip again. I'll try and take it off with the iron, yeah. If not, I'll just use a little bit of braid. Again, a little bit of flux on it will help. A bit of braid. Here we go. A little bit of flux. Okay, we're in shot, yeah, good. And we just clean that bit. Of course, it migrated to the next one. So you can see I've got the first so many pins, yeah, and that's how I do it. So I'll now go around the rest of the chip, and I'll solder all the rest, and then we'll carry on when I've actually got it stuck down. Okay, so I've gone all the way around the chip, doing what I just showed you, yeah, which is pushing down, and I'll just clean these off a little bit. So now the next step is to make sure we've soldered all the pins, and the easiest way is to just touch them with the end of a very fine tweezer, yeah, and see if they move. Can you see this one's moving? So the first one's okay, the second one's okay, the third one moves, yeah. So that one isn't soldered, so we need to fix that one. A little bit of flux, a little spot of solder, and we can come in. I'll try to do it from this direction. I may have to turn this round actually. Yeah, I'll have to just turn it sideways to make it easy for me. Okay. Well, say make it easy, make it easier. Yeah, make it easier for me. Okay, so third one up this side isn't soldered. So now, yeah, add a little bit of the 0.2mm solder, leaded solder, and just go for the one that you know isn't soldered. Yeah, third one in. There's there. So what I'm doing, if you look, I'm actually just touching the edge of the pin. A little bit of solder on the iron and touching the edge of the pin. Yeah. So that third one down is the one that isn't soldered. So let's see if we've got it now. Yeah. So one's okay. Two's okay. No, see that one still isn't soldered. Okay, so we maybe have to put a little bit of pressure on it. So I've cleaned the end of the iron, and I'm now going to try and push down on it. So I'm pushing down on several pins at once. Yeah. Let's go back again. So one soldered, two soldered, three's now soldered, four's soldered, five is soldered. It looks like it. Yeah, it doesn't move. 6, 7, 8, 9. See number 10? Can you see that moving? Not soldered. Let's try the same method with this one. A little bit of flux. Which one was it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it's that one underneath. Yeah, that's the one I wanted. A little bit of flux. Tiny little spot of solder. Push down. Yeah. Solder 11, soldered 12, soldered 13. Yeah. There's one that isn't soldered. That one's moving. Next one's okay. Yeah, I've got a few here that aren't soldered well. So let's do that part, yeah. And then basically I'm going to go around the rest of the chip doing exactly what I'm doing now, yeah. Just tagging down any pins that I think of, well, that I know by touching them they're not soldered, yeah. So it's much the same. Push down, give it some heat. Push down, give it some heat. You notice that although I'm hitting like 4 or 5 pins at once, they're not bridging. That's the flux, yeah. Soldered. I'm not this one. I'm not 100% sure. No, it says it's soldered. These are all soldered now, yeah. Yeah. So basically, guys, I'm going to go around this chip, all 4 sides, doing this, yeah, and making sure that everything's soldered. But everything's lined up now, so it's quite easy to do this. It's just a little time consuming. It's not difficult, just a little bit time consuming. Okay, see you soon. Okay, so I've been all the way around it, and there we have it, soldered. Don't be scared of this sort of thing, changing this sort of thing. What I suggest you do if you're not used to this sort of work, yeah. You don't need the fine soldering iron tip. You've seen what I'm using, yeah. BC3, yeah, you've seen it. Yes, you want some fine solder. This is 0.2mm, yeah. 0.2mm leaded solder. So yes, you want what you want. I'm getting the shot. It's there, yeah. You want some decent solder braid. You want some flux, and that's it. What I suggest you do is, say if you're new to it, is practice. Find some scrap board, and I was wondering if that was a solder edge. Find some scrap boards, yeah. get a scrap on, unsolder the chip, and then see if you can solder it back on again, yeah? See if you can solder it back on again. So we'll give this a final inspection. What I normally do at this point now, and I can see straight away, I have one pin there still not soldered, yeah? So let's just deal with that one. You can pretty much tell if they're soldered or not just by looking at them. But just by looking at them isn't really good enough, yeah? What you need to do to know for sure is it soldered, yeah? Is every pin soldered? Is there any shorts, yeah? I've got that one, you can see I've got it. So what I do now at this point is this. I get my meter, so let me just put the meter where you can actually see it, yeah? Let's get the meter into the shot of the camera. Just take me one moment to find my mouse pointer and move over. So there it is, yeah? Let's make sure we're recording. Meter on ohms mode, yeah? So what you'll see is you can do now if you're watching the microscope. Let me zoom it in a little bit as well so you can see very clearly, yeah? It's focus good, I think so, yeah. Okay. So it's quite easy to get 1 meter probe on the pin, yeah? And it's quite easy to get the other one on the pad without touching the pin. And that will tell you if you have continuity from the pad. Yeah? So one on the pin, obviously you want some 5 meter probes, and one on the pad. Yeah. The other thing you can check is from each one, is it shorted to the next one? Yeah. Doesn't matter if it's short to this one. I want to know if it's shorted to the next one. Yeah. So you can stick in between the two easily, then just touch the pad, and you can work your way along this chip, just making. That's what I'm connected on. Making sure there's no shorts. Yeah. So first of all, I'm looking continuity. Yeah. And then secondly, I'm looking for a short to the next pad. Yeah. And I think I got back as far as here. So again, let me just do this and I'll see you guys in a moment. I'm going to go all the way around this chip. Okay, I've done the first side. I'm just on the second side and I want to show you this one. This is how to build up a kind of like a rhythm, yeah? So first of all, first pin and C, we're touching the pad on the board, not the pin, yeah? And is it short to the second one? No. Okay, now we can come stick this probe in between the first two pins. Continuity yes, next one short, no. Continuity yes, next one short, no. Continuity yes, next one short, no. You see I'm going like a ladder. Continuity next one short, no, yeah. Continuity, is it shorted? Continuity, is it shorted? Continuity, is it shorted? Continuity, is it shorted? Yes. And can you see it in there? A little bridge of solder there, yeah? So we need to just deal with that. I'll try, without flux, it might need some flux. So in here you can see I've got a little bridge, yeah? Let's just clear that out and that's down. Let's carry on, make sure we've still got continuity. So, let's come back in again. Do I have continuity now? Yes. Shorted? No. Continuity yes. Shorted no. This must have continuity. I can see it's soldered down. Well, you'd think so, wouldn't you? Continuity yes. Shorted no. You've got to make sure you're touching the board and not the pin. Yeah, so when you check the continuity yes. Shorted no. Yes, continuity. Sorry, fingers gone stiff. Yes. Continuity, shorted, no, yeah? Yes for continuity, shorted for no. And we can just keep working our way along this chip like this. Continuity, shorted. Continuity, is it shorted? Continuity. Do we have continuity on this one? Obviously due to the pin. But I'm not. Yes, we do have. Just wasn't making a good contact on the pad. Yeah. And is it shorted, by the way? No. Continuity, is it shorted? No. I need some new meter probes. These needle points are not needles anymore. Basically. I'll put them on order. continuity's there. I'm cramping one of my fingers. Continuity not shorted. Do we have continuity on this one? Yes, we do. Not shorted. Continuity. Not shorted. Not short. Sorry. Do we have continuity on this next to the end one? Yes, to the pin. I'm not sure about that one. Obviously it is to the pin. Yes, I do have. I had it for a minute then. No, I'm not sure about that one. So that one next to the end, we just need to come back in with a little bit of heat, yeah? I'm not holding on to the pin, I'm just going to the side. There we go. This is out of spot where they're not connected even if you think they are, yeah? I know you might think this is tedious. Yeah, but this is the way to do the job. Yeah, I got it that time. Is it shorted? No, there was no continuity. Yes. Okay, so there you go, 2 sides to go, and I won't make you sit and watch. Okay, so there's our Super I/O soldered from the donor board. Yeah, apart from the one solder bridge I found this down this side. There wasn't any, one pin that wasn't soldered, everything else was fine. But that shows you why you need to go around and double check, yeah, everything's soldered, nothing shorted. On that last section, I didn't realise the test meter had fell over and you couldn't see it, but I'm sure you could hear it bleeping as I'm trying to say, look, I've got continuity or I haven't got a short, yeah. So yeah, we're ready to go. I've put the CMOS battery back in now. I'll just zoom out and we'll connect everything up and we'll see what it actually does now. I've got it zoomed out. I'm just going to have a look actually again, just check the current on the CMOS battery, see if that's same or changed. Let's see what we have here. 6.9. Isn't that what I read on the other board? And this one was really different. I'll have to go back and review the video now, but I think that's changed when I've changed the Super I/O, and I think it's changed like the other one was. Yeah, different current. If that's the case, that actually might be a positive sign. Let's get the heatsink on here. Yeah. I won't put any RAM in again. I'll connect the switch and I'll try and find my bleeper, which I think fell on the floor, and I'll connect the bleeper. There's my bleeper. So with no RAM, speaker connected, power switch connected, 12 volts, yeah, everything ready to go. Just make sure there's nothing got under the board. Yeah, look, you see. Especially when you've been working, you need to always check. Yeah, so that's looking. Yeah, it looks alright. We don't have anything stupid going wrong at this point in the game, do we? Okay, so power supply on. The big moment. Does it start? And the answer is no. It doesn't start. So that didn't gain us a lot, did it? I assume I've got the 5 volts standby. Yeah, 5 volt standby still on. Okay, so that was kind of a bit of a wasted effort, really. But it, for whatever reason, it still doesn't want to start. Does it still want to bleep or do whatever it does if I force it to run? Yeah, let me just find a bit of wire or something I can just stick down the green wire of the power supply. My old 22 ohm resistors, that'll do the job. Let's see what happens if we force it. Yeah, so black to green, black, yeah, green. No, it doesn't start this time. Just the LEDs come on. It doesn't actually boot. Oh. I told you sometimes it bleeped, didn't I? Told you sometimes it bleeped like it was trying to boot. Fan isn't running, it's obviously trying to boot. Now it's gone off again. Will it do the same thing if I try and start it again? Yep, that power's on. Let me get my post analyzer. Yep, post analyzer's in there, camera, yeah. So you can see it. It's there, yeah. I think I've kind of got it in the shot. There you are. Power on. Reading 0, yeah. And then somehow it started to bleep. Press the button. Now it won't do it again. So it's a funny thing that it's like the first time when I power it on, it's something that this actually goes to C1. I didn't see it this time, but previously I did see it do that. And it kind of like tries to power up. Ah. It does it when I actually take the ATX power supply thing off. It does it when I take that off. That's fun, isn't it? So power supply, and then it switches off. So it started it up, yeah. Started it up. Disconnect the wire. Well, that's how it just went off. Wonder if it's after a certain period of time. Let's switch it off. Switch it back on again. Set my resistor legs down the wires again. So black to green. All these LEDs come on, yeah. Doesn't do anything, and when I'm going to disconnect this, I think this is when it started bleeping previously. Now this time it just went off. So it didn't help a lot, did it really, changing this? I mean, to be quite honest, I changed the SIO because I happen to have another board with the same SIO, and I thought, well, especially I know on laptops, it's a lot to do with power management. So, I mean, there was no harm, just, you know, used a bit of time up, but I think we, you know, learned a bit, gained some experience of changing these chips. So can we do anything else with this? Well, yeah, I think we can. I mean, the next thing really we need to be thinking about is the chipset, yeah. And in these cases, I may have more luck actually finding a datasheet, and it might give us some useful information. So let's have a look to see what we actually have, yeah. I'll get the microscope, just see if the microscope camera is working, and let's actually have a look to see what we actually have here. Yeah, okay, got the microscope camera working. So this is the PCH, or South Bridge it was called, and we can see it's an IFPKHBCS, yeah. And this chip has quite a lot to do with the power management and the starting up of the computer, yeah. The other chip we can see here, let's just turn it round, this is the right way up, AC82P45, yeah, this is your P45 chipset. It's quite commonly, to be quite honest, Intel will actually have the data sheets for these chips. So let's have a look on the internet and see what we can find. I think this might tell us something quite useful. Okay, let's have a look. Okay, so yeah, had a look on the internet, and yes, there are data sheets for these chips, which is very handy. This is the 82801JIR, yeah, and also I found the other one as well. So let's have a look to see what we have, yeah. This is the data sheet for the North Bridge, if you like, yeah. And in here, if we just have a bit of a scroll down, it will give us a block diagram, which is quite handy because it kind of explains how this thing is all connected up, basically, yeah. So just find the block diagram, it's here somewhere. There we go. So this here, this is the North Bridge, yeah. It's actually a memory control hub these days, so you can see it's communicating directly with the processor, yeah. It speaks to channel A and channel B on your memory, DDR2, DDR3, and it also communicates with the PCIe slots, yeah. This is your south bridge, yeah. This is your 82801JIR. Now you can see here, this is the SIO. This is what I changed because I had one of the same. I thought, oh, well, let's just see if it makes any difference. And it didn't, yeah. But you can see this chip actually handles power management, yeah. So if we go over to the datasheet for this chip, you know, the 82810, and we have a look down here. I mean, this is a very long datasheet, yeah. There's a lot of information in this. But if we look through the contents, you'll see it has a functional description, and it's talking about the various things: DMI to PCI bridge, PCI Express, Gigabit Ethernet controller, and so on, yeah. DMA operation, yeah. And if we look down here, we will find the section that we're interested in: serial interrupts, real-time clock. We're getting more towards what we want. Power management, yeah, from page 142. So let's go and have a look to see what's happening down to page 142, yeah. Just a little bit past this, here we go. So this is talking about power management, yeah. And if you look through here, you'll see this is where your on-off switch effectively connects to, yeah. And this chip is responsible for all the power states. Powering it on, switching it off. You know, when you hold your on button for 3 or 4 seconds, it switches off. It goes to sleep mode from software. All that's controlled from here, yeah. And it mentions the various sleep signals, and also it will mention the fact that the power button is connected into here as well. Just scroll through it. Maybe a little bit too far. Power planes. This is basically explaining how we go from the various, you know, sleep mode to on and such like, yeah. And I'm sure in here I did see it. I had a quick look down here, and I've seen these data sheets before. It will actually explain that the power switch is connected to here, yeah. Transition rules. This is explaining how it gets to the various states, yeah. Sleep states. Initiating sleep state. Exiting sleep states. This is where your power button comes into this. Handling power, there we go. Handling power failure. So it's explaining about the power button always enabled when you first switch a machine on. Tells you here what's happening after reset, yeah. After power returns, this RSM reset goes high. Power button is already high. That we know it has 5 volts on because you can measure that, yeah. Explains why, because reset goes high. Standby goes high before reset. The signal goes high. Okay. So this is where your power button actually connects to, and that would suggest this is where we should be looking next. Yeah, in fact, probably where I should look before, to be quite honest. Never mind. Looking next again, it's explaining the operation of the power button, yeah, and the various ways it works. So we know this chip handles all the power functions for the computer, yeah. So we know this is where we should be having a good look, really, to see what's going on. Okay, so let's go back over to the workbench. So this chip basically is involved with a lot of the signals that power the board up, yeah. And I had a look on AliExpress, and you can actually buy these. It might be an idea to change this. The problem with these, you can't really probe underneath it, yeah. There's no way to get underneath here. If I had a board view, I could look up the various signals I'm interested in, and then I'll probably find pull-up resistors that are on the same signal, yeah, the same line basically, and I can probably, by probing around the components around here, with the benefit of having a board view, I can actually check what the various signals are doing. Unfortunately, I don't have a board view of this, so I'm working more blind. But I could change this. If we have a quick look on AliExpress, I'll show you how much these are. They're quite cheap actually. Let's just have a look at that. So this is AliExpress, yeah, and you can see here, this is the chip, €3.93 with shipping, €4.67 with free shipping, yeah, so less than €5. Also, like 5 have been sold, yeah, and the fact that people have actually bought these makes me suspect that these sometimes fail. If you see, you know, people are buying them, that's a good indication that they go wrong, I would say, yeah. Another one a little bit cheaper, it's still about €5, whichever way you look at it. So, I found one a bit cheaper now, €3 or something. I could buy one and we could change this, but what I'm thinking is, first, to try and rebuild the one we've got. Yeah, I mean, it might just be, you know, it's worth a chance. It might just be effectively that the soldering is bad under here. I mean, you know, the board's quite old, might have been flexed a little bit. So what we'll do is we'll change this. Yeah, we'll make another video. I'm going to end this one now because it's getting too long. Yeah, too long. Yeah. So we'll do another video. We'll change this chip. We'll take it off. If it comes off nice and cleanly, we'll rebuild it and we'll put it back on again. And let's see what happens. Yeah. If we're still getting nowhere and the symptoms haven't changed, so I haven't effectively messed something up, yeah, then we'll just get another one for €5 and we'll change it. Be a good experience. Okay, so let's call an end to this one here. Hope you enjoyed it. A bit in depth, but you know these repairs do go in depth, yeah. And I'll see you soon with this motherboard on another video. See you soon, guys.